My name is Colby Barth. I'm a distinguished engineer at Juniper. I've been at Juniper, I just celebrated my 8th year at Juniper. In those 8 years, I've worked almost entirely in our MPLS protocols group. Prior to that, I was at Cisco Systems for a long time, 10 plus years, also doing similar stuff. I'm going to talk today about traffic engineering. And before I get started, I have a disclaimer on my next slide, but this is my agenda. I really just want to talk generally about traffic engineering. I'm going to cover a couple of main topics, this presentation could probably be a week-long presentation, at least coming from me. I love traffic engineering. I only have 20 minutes to talk, so if any of this is interesting, please catch up with me later. I'll talk your ear off, or tonight at the bar. But I'm going to talk a little bit about tactical TE. Well, I'll start by defining TE, at least in my context. I'll talk about tactical traffic engineering, and I'm going to take some specific shots at that. I'm going to talk about controllers. In the last few years, I've spent quite a bit of time at Juniper working on our controllers, specifically our PCE program. I'll talk about protection and looping as well. Again, having done traffic engineering for the better part of 15 years now, sort of looping and protection are near and dear to my heart a little bit when it comes to those topics. And then I'll make some sort of recommendations at the end. I want to sort of throw an initial disclaimer out saying that my recommendations they're just my recommendations. They're 15 years of experience. They're working at a vendor for most of those 15 years. So take them with a little bit of a grain of salt. All right, so here's my official disclaimer. I only have 20 minutes. I love to talk about traffic engineering, so please catch up with me afterwards. It'll at least make my afternoon really interesting. This is not a presentation about comparing and contrasting RSVP and segment routing. In fact, my hope is that when I'm done today, whether you've decided to do traffic engineering in your network, you have the choice of using one of a myriad of techniques. And quite frankly, they don't matter to me. What matters to me is the end result, which is traffic engineering. I am going to mix and match segment routing and RSVP terminology. Hopefully it doesn't end up to be confusing, but I'm mixing and matching it to try to, say that it doesn't matter, right? Because traffic engineering is still traffic engineering. And then, I've said it twice already, but I'll keep saying it. Please catch up with me afterwards, because I'm going to talk super fast, and I love to talk about this stuff. Everybody okay with that so far? All right, so what is traffic engineering? I interact with a lot of people internally at Juniper, probably less so on the actual customers, but I interact with most of our field guys on a daily basis. And the way I define traffic engineering is anytime we want, as humans, for traffic to take a path that is not the shortest path as computed by our IGPs. Now, why you want that, everybody has a different reason. And in fact, if I had a nickel for every time someone described auto bandwidth for me as a use case for something they want to do, I'd be retired. Right, so bandwidth and what I call resource optimization continues to be, I think, the sort of the quintessential traffic engineering use case, regardless of what most people call it. Now, we have things like disjointness, right? So you can think of diverse paths and whatnot. There are lots of customers who have regulatory concerns. We have lots of use cases in North America where my Canadian colleagues really don't want their traffic to enter the U.S. And then we have, of course, application performance. Application performance is a tough one. I struggle with it a little bit. It's hard for me to measure and then apply it to sort of how routers route packets, because our routers don't really look at apps too much. And then, of course, there's lots and lots of other use cases. Constraints. You'll hear me, if you talk to me a lot about traffic engineering, I always talk about routing constraints. I rarely talk about anything other than tell me what the constraint is. Tell me what you want to do. Give me an intent, if you will. I know intent-based networking is a new fashionable word these days, but to me, a routing constraint is an intent, right? Now, once we define a constraint, we need to use all of these attributes of the network in order to compute a path, right? And I've listed all of them here. Now, we have traditionally dealt with things like affinities. We would call them colors. I think that's what we actually make you type into our CLI. Metrics, shared risk link groups, bandwidth availability. Those are our sort of traditional link attributes and network attributes that we deal with when we try to route something. Now, segment routing does something interesting for us, or maybe not so interesting, but challenging. Right? We now have new constraints. We have something called a maximum SID depth, and we have a maximum readable label depth. Right? I feel as though in the conversations I'm in with our customers and field people, people tend to wave their hands at these. But to me, these are routing constraints. If you define an intent, and your intent is to compute a path, I need to make sure that that path can be computed such that a maximum SID depth is also handled as a constraint. Right? And then last but not least, things like node attributes. I know they're being introduced in the IETF these days. We've traditionally used them in our offline tools and our path computation elements. And then there's a bit of maybe an eye chart, depending on where you're sitting here. No, it just doesn't work that well. Anyway, I've tried to list them all out there for you. Okay, so on to more interesting stuff. How do we describe a path? Again, this is something that I see a lot when we start talking about segment routing. Humans, and myself, I'm guilty of this as well, we tend to describe things as go to this router, and then go to this router, and then go to this router. But CSPF doesn't work that way. Traditional CSPF computed go to this interface address, and then this interface address, and then this interface address. And we always computed a very strict path. Now, this notion of a strict explicit route object has become a bit of a dirty word over the past couple of years. But we did it for a reason. We do it because it avoids loops. Right? So a human can still describe something in this sort of abstract, intent-based way, but the mathematics underneath describes this very explicit path. And I'll touch on the looping stuff later. But I've tried to sort of depict that here. Okay, ECMP, another good one. ECMP is not new. Right? Link bundles and lags have been around forever. They've been a particular thorn in lots of us vendors' sides for lots of reasons. I'm sure thorns in your sides as well. Lots of people have deployed, what I call here end by ingress LSPs. In fact, you could probably corner some of your LINX colleagues here and get them to explain what they do. But they deploy and they leverage ECMP by having lots of ingress LSPs, and all of the load balancing happens on ingress. I specifically point this out because this is something that will be a challenge moving forward as we migrate to more Spring TE-based architectures, because we lose this notion of state, if you will. It's all shared state now. And then we have things like RSVP ECMP, which has been developed by at least one vendor and deployed. That's a plug for Juniper there. And then there's been lots of tools, or not lots of tools, but there's been at least a few attempts over the years, I think back in early 2000s, to do IGP metric-based TE. And I'm not sure if there's anybody out there who's currently using it. I know there are deployments of it, and it is in use as an effective TE tool. It comes with, as an RSVP, or traditionally an RSVP traffic engineering guy, I always struggled with it just a bit, but it is an effective tool. And the idea was to create ECMP on your networks. Now, I'll go on to say that ECMP is becoming increasingly popular with data centers. Right? Everybody wants to replace their PE models with spine leaf models, and I have lots and lots of ECMP. But if you sort of take a logical progression there, the way to make use of it is to go back and reuse the tools we've been using for a while. But generally speaking, at least in the US, we have very little pockets, very, very small pockets of ECMP, unless we're already doing some of these techniques. Okay, so I'm going to pause on this one and slow down a bit. I guess I got, what, 9 more minutes? Yeah, okay. So strategic TE versus tactical TE. I think there were books written about this way back in the day. I think a colleague at Cisco read a really interesting book about tactical TE. But I am a hater of tactical TE, and I won't mince words about that. And the reason for it is humans are forgetful. I'm forgetful. And I've watched a number of hacks go into networks in the last 15 years, and hacks never leave your network. Right? They become hacks, and they become problems, and they become test cases that vendors have to continuously try to work around, and then we end up with problems and bugs. So I would argue that the moment you decide that a service or you want TE, you should traffic engineer everything. All right? And the rationale being that if we don't traffic engineer everything, or I'm making an assumption that what you want to traffic engineer is important to you, and if we don't traffic engineer stuff that's not important to you, then the non-important stuff will step all over your traffic engineered stuff. And this becomes increasingly important as we move forward with segment routing. Again, because of this sort of shared state nature of things in the core. So traffic engineering requires a plan from the start, and I think it's important that the moment you decide to do TE, you decide to create a plan for yourself globally. And not sprinkle some TE here and use a little shortest path stuff over here. We'll end up with problems. And I can talk, I'd love to talk a bit more about this in depth afterwards, because it's sort of a Juniper or Junos nuance in some regards with our INET3 and INET0 tables that some of you guys hopefully are familiar with, where this becomes a real problem, or a real challenge, I should say. Everything's going to work fine, but you're going to ask us to do something that's very difficult and will cause you problems. And this is where it starts to become a problem. TE controllers. They're also not necessarily new. We've rebranded them a little bit because of this era of SDN. But we've had offline tools for doing traffic engineering management for 20 years. They started back when we had ATM networks. In fact, Juniper acquired one of them. It was called Wandle. If you look at the guts of the Wandle code, there's tons of code in there for managing ATM frame relay networks. Right? And they're managed similar to how we manage RSVP networks, and they're managed similar to how we'll manage SR networks moving forward. But this concept of a stateful PCE introduced this idea of making basically near real-time path computation adjustments on your network. Right? And we can make those near real-time adjustments if we have real-time data. Okay, so a PCE as a TE controller requires real-time data. And I'll come back to this in a little bit later. Offline tools like Wandle, or I guess we market it now as Northstar, or Keratin's Mate, or Cisco's Mate. They are offline tools that were pretty good at exhaustive failure analysis. They sort of brute force crunch through lots of computations. But doing real-time path computation and exhaustive failure analysis are very different, both on a time scale as well as the data that they can use to do that work. And you can't necessarily do exhaustive failure analysis very quickly. And PCEs that operate in near real time aren't doing exhaustive failure analysis. But in both cases, data acquisition is the key. All right? Which brings me to the devil's in the details with these things. And this again is my opinion after the last couple years of experience with Northstar. It's best not to make us guess. Right? Offline tools are really good at guessing. Right? They try to figure out what your network will do given a set of circumstances, a whole bunch of constraints defined for your label switch paths, and then they would crunch through data. But there was no guarantee that they were actually correct. They were just sort of correct. And so we would see customers sort of size up their links by plus or minus 5 to 10%. It's a bit of a broad swag at a long-term capacity planning plan. Whereas TE controllers are expected to be correct. They're expected to tell your network what to do. And so if I have to tell your network what to do, I can't guess at what your router's doing. I want to tell your router what to do. Routers today don't report how they resolve routes. Right? And it's a really important thing that we need to develop in the industry. So please go ask your vendors to do this stuff for us. We're trying to do it. It's a difficult problem. But if you think about some of the use cases that people are describing, they're describing things that require us to understand how the router resolves a route and or program that router to make a specific resolution. So imagine if I wanted to, quote unquote, program billions of routes into a network. That would be a relatively unscalable task. So I need to understand how the routers are resolving things so I can optimize what their resolution behavior is. ECMP is terrible for controllers. Right? It's an effective traffic engineering tool. I know it's really sexy these days with data centers, but controllers have to guess. We're never going to get it perfect if the routers have to report to us exactly how they're doing ECMP. Right? We're talking terabits and terabits and terabits of data thrown at a controller. So ECMP is kind of a terrible problem for us. And then last but not least, this goes back to I think my third slide or my second slide about the loose hops. Loose hops are also terrible for us as controller people because I have to guess. I want the routers and I want the network to tell me exactly how an LSP is routed across the network. I don't want it to say, well, we're going to go to this router, and then we're going to go over here to this router, because somewhere in the middle, the routers are making decisions that they aren't telling me about as a controller. So it's best not to have to guess if you're relying on a controller. Protection. Protection was, I think, a big use case in the early days for traffic engineering. In fact, I've heard lots of people, or had lots of customers who only used RSVP for protection. And we did tricks with like one-hop LSPs and neat, clever stuff like that. But one of the things that was always a comfort with protection was that FRR honored the constraints of our LSPs. And the classic example was bandwidth. Right? If you would reserve bandwidth for a bypass LSP so that you were guaranteed that that bypass LSP would carry all of the associated primary LSPs and they would have bandwidth. Right? This is something that we're going to lose moving forward. Now, not everyone made use of it, so it may not be that big of a deal. But this notion of shared state in the core of a network, we lose the ability to honor constraints for our primary associated LSPs. And then this last thing is a bit of a poke at TI-LFA, and it's shameless. But I'll say that this idea that TI-LFA always computes this perfect post-convergence path is marketing. Right? It's a shortest path from the point of local repairs perspective, not the shortest path from the ingress router's perspective. So RSVP does the exact same thing, is I think the point of this slide. But that's like I said, I'm throwing some opinions in here just for fun. Looping, I'm going to speed back up again because I'm about to run out of time. RSVP prevented loops. So again, if I go back to this idea of creating a loose hop, if I create an LSP where I define a router's node address as a hop, and something fails along the path to that router, it's possible that I would try to signal an LSP in an interface and out the same interface. RSVP as a protocol prevented that from us, for better or worse. I know I would have argued, I don't know, maybe about 10 years ago that was a terrible thing because I stayed up all night to troubleshoot a problem that I created because I made a loose hop. Segment routing won't do that. Segment routing does, because we encode it in the packet, loops are okay. Right? Now, as a becoming sort of an old person in the industry, maybe, loops are bad. So how do we figure out if we create loops? And are loops okay? Now, I'll say that as a tool guy and working on Juniper's North Star, right, we do not tell you if you have a loop in your network today. It's something that we have to build into these offline capacity planning tools. So in addition to sort of like crunching through exhaustive failure analyses, we're now going to have to sort of crunch through, does a failure cause a loop as we move forward with segment routing, traffic engineering architectures. And then this is my last slide. So I know this is all just I just threw a whole bunch of stuff at you guys, sort of like just throwing crap at the wall. But like I said, I only had 20 minutes to talk. These are things that bother me and that I work on at Juniper and interact with my customers, or more so the field guys who presumably interact with their customers. But basically, segment routing has some new routing constraints that we have to work through. We need to enhance our algorithms, and whether you call it CSPF or whether we invent something new like K-path stuff, we need to start accounting for maximum SID depth, and we need to account for maximum readable label depth if we're going to do things correctly. And waving our hands and saying, we're going to compress label stacks isn't an answer, because we want to be specific. Being specific, in my opinion, is important. We don't want loops. We want to rely on controllers to help us do things, right? Because we want to describe intent and then let the controller do it. So the controller needs to be specific. A full mesh of TE LSPs is going to make your life easy. Right? Now, I don't know how every other vendor has implemented things, but in Junos, if you use Juniper routers, please use Spring TE LSPs and don't rely just on labeled ISIS routes or labeled OSPF routes. Right? Because you're sprinkling tactical TE around on things. And then last but not least, I've mentioned it a couple times, but I decided not to include it because I think it would have extended my presentation too much. But stats are really, really, really important for all of these things. And we need to invest in new forms of stats collection as we move forward with segment routing networks. Because we can't do label counters anymore, because we only have one shared label now. So we need to really invest, I guess, in net flow collection and accurate net flow collection and all of that kind of stuff. And that's it for me. I am 4 minutes over, and I apologize. If anybody has any questions, you can shoot them over quick, or I'm sitting back there, and I'd love to spend the rest of the day talking about TE. All right. Silence is good, I suppose.
Excellent.